Welcome to the second half of Chapter 7. So if you remember a while back, when talking through the first half, we were focusing on exponential functions, all right? Now we're going to talk about the inverse of that, the opposite of that. And the opposite of an exponent is called a logarithm. So this right here, this is the basic form of a logarithm, and how you read it is log base b of y, okay, with a couple of restrictions. B has to be greater than 0, but cannot be 1. And what a logarithm really answers, so it answers the question, what power does b need to become that value y? Okay, so that's what a logarithm is what power does that base need in order to become that main number? Okay, so now, how is it going to answer that question? What really is a logarithm? Well, logarithm is actually an operation, okay? Just like adding, subtracting, multiplying, dividing, square rooting. It's an operation, and it can be done to both sides of an equation, okay? And so let's take a look at what it does. So logarithm cancels the base of whatever you're focusing on. So in this first question, that one right there, notice that it has a base of 2, right? 2 to the 5th power. So what I'm going to do is I'm going to take log base 2 of both sides. Okay, and the reason I'm doing that is because, again, this operation, it undoes that base. It sets free that exponent. Okay, so that is the exponential form, or sorry, the logarithmic form of this equation. Log base 2 of 32 is 5. And again, the logarithm is answering the question, what power does 2 need to become 32? Well, it needs 5, and that's the solution to this equation. So let's focus on the next one. So this next one, I see a base 3, okay? And then the logarithm is going to undo that base for us. So I have to log base 3 both sides of this. Because in taking log base 3, that's going to cancel that base out. They undo each other, setting that exponent free. And once again, if you notice, this logarithm does answer the question. What power does 3 need to become 81? Well, it needs 4. So that's the answer to that logarithm. It's what that logarithm equals. All right, and another one. So here again, notice that base 5. So I need to use the appropriate logarithm. All right, and again, as always, the logarithm undoes that base to solve for the exponent. So our answer is -3. So what power does 5 need to become 0.008? Well, it needs a -3 power to do so. And the other interesting thing is you can even do this when you don't have actual numbers. You can do this with variables as well. So here, notice I have base A. So that is what I need. Okay, I'm going to log base A both sides. To undo that, sets the B free. And you'll end up with that. Right, so again, really these logarithms, just think of them as an operation. A logarithm is something you do to both sides of an equation, okay? Now, that's how you can go from exponential form to logarithmic form. Now, later it actually is important as well. How do you go back? Okay, so both directions of this are important, going from exponential to logarithmic, but then also how can I go from logarithmic form back to exponential form, okay? It's important to know both sides of this coin. So here, I know this is awful and cheesy, but the way I learned it from my teacher, he called it Mr. Loopy. And again, if I remember it this many years later, it absolutely stuck with me. Okay, so that's how I want to show you guys how to do this. Okay, to go from a logarithm to put it back to exponential form, we're going to perform what's called Mr. Loopy. Okay, and the reason we call it that is because you basically loop around the equation. So you start at the b. So b to the x power. B to the x equals, then you go back, you loop back to the y. Okay, and again, it should make sense to you because we're talking about the logarithm talks about what power does b need to become y? Well, that power that it needs is that x. So ultimately, this does make sense. This is how you go backwards, okay? But you do just want to make sure you understand how to go fluidly between these two forms, okay? And here, I think the most obvious way to remember is Mr. Loopy. So let me show you a couple of examples of that. So rewriting these in their exponential form. So again, let's take 3, loop over to the 5, 3 to the 5th power equals loop back to the 243. So 3 to the 5th equals 243. And you can actually check that that indeed is true. You can plug that in the calculator to confirm that. Here, 3 to the negative 2 power equals, loop back, that's going to equal 1/9. And again, you could confirm that in the calculator. And what about this one? Well, 25 to the 1/2 power, loop back, equals 5, which again makes sense because you know a 1/2 exponent is the same as a square root. So the square root of 25 is in fact just 5. So again, all these make sense when you go back and forth between these forms. You can verify that that is a true equation. Okay? And now we can even talk about one of those conditions. So when I started this formula, we talked about that b can't equal 1, okay? Now let's think about why, okay? So here, let's write this in exponential form. So 1 to the x equals 3, okay? So if we're thinking about the solution to that, what x could make that true? Well, let's try. So we have 1, let's try 1 to the first power, 1 to the first power. Nope. 1 to the second power. 1 to the third power. I mean, that has to be right. There's a 3 in the equation. Oh, still 1. Okay, so what you're going to notice is 1 to any power remains itself. So looking at that, it makes very little sense to let 1 be the base, because no matter what the exponent is, it's not going to change. It's not going to be able to equal anything else. Okay? So that is why b cannot be 1, because no matter what power you put on it, it's not going to change. So why logarithms? Okay, that's probably one of the biggest questions of math. Why are we learning this? What can it do for me? Well, we learn about logarithms so eventually we can solve equations like this. And of course, yes, they're going to get more complicated than that, but let's talk about the very basics first. Okay, so logarithms you can use to solve for that x, because remember, a logarithm can break that exponent free from its base. So this has a base 4, so I can base or log base 4 both sides. Okay? It cancels the base and leaves me with that. So the reason logarithms are important is because I need to be able to know how to interpret that. I need to be able to understand, well, what does it mean when I say log base 4 of 64? It's a solution to that equation. I solved for x, but I need to know what that means, okay? And so we're going to talk about the basis of that for the rest of this note video. What does it mean to have this logarithm? What is its answer, its solution, okay? So remember, to evaluate a logarithm, there's two ways you can think of it, okay? So for basic ones, you can think of it as, oh, okay, what power of b is going to give me y, all right? For harder ones, we're going to want to think of it as finding a common base. Okay, so let me explore this idea with you. So what power, so here, if we're looking at 5 and 125, so on the surface level, what it's really asking is what power of 5 gives me 125, okay? That's really what it's asking. Now, there is going to be a non-calculator portion to this test, okay? So you are going to have to know how to do some of this without a calculator. So let's see here. I need to know what power of 5 gives me 125. Well, here this is showing me 5 to the third, okay? 5 to the third power is 125, okay? So some of you right away will see, oh, all right, 5 to the third, boom, I'm done. Now, on the shallow level, that's all that you really need, okay? For today's notes, that's going to get you by. Now, you are going to have to understand the more complex ones. We're going to get some harder ones tomorrow. And for those, it's probably a good idea to also understand what you're doing is you're turning that 125 into a common base, okay? You're reshaping the 125 as 5 to the third power and really canceling off that base to be left with the 3, okay? So again, depending on the complexity of each problem, it's going to change how you want to view it, okay? So again, for today, for the most part, you can look at it the easy way, okay? So for example, for that one, log base 6 of 36. So you're asking yourself the question, what power does 6 need to become 36? And again, the resource you'll have for your test is going to be this powers chart. So what power does 6 need to become 36? Well, 6 squared gives me 36. So my answer to that one is simply a 2. I need 6 to the second power. What power does 7 need to become 343? Again, this power chart is really going to help you. 7 to become 343 needs a third power. Okay, so that is going to give you a 3. What power does 2 need to become 16? Again, the resource for your test is going to be this. So what does 2 need to become 16? Well, it needs a fourth power. What about one like this? What does y need to become y to the fifth? Well, to answer that, that's the very foundation of what a logarithm is, right? So here, wouldn't that log cancel the y itself? And it would actually just leave you with the exponent of 5. So that one, again, you're just using the very nature of what is a logarithm. Logarithm is going to cancel that base to leave you with the exponent. It's telling you what exponent you need. Now, there is one thing to know about this, okay? So, the common logarithm. So notice here, this just says log 100. It doesn't give you a base, okay? And the reason for that is because this one is so common in real-world examples that they neglect the 10, okay? So if there's no base written, it is assumed to be 10. And maybe in the beginning it's best for you to write that 10 in, because you are going to have to recognize that that is a 10, because you need to answer the question, well, what power does 10 need to become 100? What does 10 need to become 100? Well, it needs a square, okay? It needs a 2. So you do have to understand that when the base isn't written, that is a common log, and that just means it's automatically a base 2, okay? And so for today, we're going to leave it at that basic level for you, okay? Give you practice with the basics before moving into the harder ones where you have to manipulate some of these bases, okay? So do take a moment, and I do want you to write that summary for me, okay? Tell me a little bit about what you learned, how you're going to remember what to do, anything like that, okay? When you're done with the summary, then just make sure you come back to class ready to do your practice work.